Good morning, students. Just wait few minutes for rest of the student to join in this session. Then we will start the session.
Hello, good morning, all of you. You are getting my voice?
Yes, sir.
Okay. So now we will start this session. I think now the screen is visible, whiteboard. Okay. Before going to start, Okay, so in the last class, actually, we have discussed about the fiber loss. Okay, so in that class, actually, we have discussed the fiber loss and mainly the attenuation loss, and we also know what are the parameters or what are the causes or uh, mm, what are the reasons uh, actually create the attenuation loss. So these are the losses, that is the absorption loss, scattering loss, bending loss, core and cladding loss. Okay, so one thing, and last class, actually we have also discussed the calculation, how we will do the calculation for the fiber loss in any optical fiber channel. Okay, so today actually we will cover these losses, that is the absorption loss, scattering loss, bending loss and core and cladding loss. And before going to start this topic, first we will do some mathematical problem regarding the fiber loss. Okay, so then we will move forward for the next topic. So I think the fiber loss is clear for all of you. Here actually just 1 minute. Yeah, at this moment 7 student is there in this class. So out of 7 students, how many was present in the last class? Who was not present? Hello. Okay, so I assume that you got the concept regarding the attenuation loss. Okay, and the formula for the mathematical problem. So in the last class I have already discussed. I already discussed. Just 1 minute. Sorry for disturbances. First of all, here I am giving you some problem regarding this attenuation loss. Okay, then we will move forward for the next topic. So first problem, that is, here I am writing a low loss fiber has average loss of 3 dB per kilometer at 900 nm. compute the length over which power decreasing by 50%. First, you will try for this problem, then we will see what is the solution for this problem. You are getting the question? You are getting or not? In the last class, we have discussed about the attenuation loss, and we also discussed the mathematical concept regarding the attenuation loss. And based on that problem, actually here we are watching this problem also. So if your concept is clear from the last class, so it is very easy to solve this problem. Are you trying or not? Okay, so there is no response. So here from this question, some data is given to do the math. So here lambda. So first alpha, here alpha equals to 3 dB per km. Alpha means attenuation coefficient, and lambda is 900 nm. So we can write here 9 into 10 to the power 9 m. So here the question, in the question it is given that power decreased by 50%. So P0 by Pz equals to 50% or 0.5, sorry. So alpha is already given. So alpha equals to 10 into 1 by z log P0 by Pz. So it is 3 equals to 10 into 1 by z log this 0.5. So with the help of a calculator, you can easily get the value of z. Okay, so z is the here length of the cable. So here it is 1 km. This is your answer for this problem. You are getting the solution. Amisha Shahu. Okay, so all of the participants are requested to write your name in the chat box for the attendance for first session. Actually, this class is for 2 sessions. So write your name in the first session. Sorry, write your name in the chat box for the first session. All of you write your name in the chat box. There is 7 students, but I am getting here. Sweta, are you getting the solution?
Yes, sir.
Okay, so the next problem I'm writing here. For a 30 km long fiber, attenuation .8 dB per km at 1300 nm if a 100 watt power is launched into the fiber, find the output. Here it is given that for a 30 km long fiber attenuation 0.8 dB per km at 1300 nm. If a 200 megawatt power is launched into the fiber, find the output power. First you will try. Otherwise, you will get this type of problem in your examination, semester examination. There is little bit difficult to solve this type of problem. And if you are getting any type of problem, or is there any lack of understanding, so you just tell. So okay, so I don't know why you are not at least saying what is your answer or what you are getting. So the attenuation in optical fibers, so here it is given alpha equals to 10 by z log p0 by pz. Okay, so alpha is given, that is 0.8 dB per km, and here wavelength, that is lambda, is also given. Okay, so now here minute 0.8 10 by 30, because here it is mentioned that 30 km long, so the value of z is 30 log, this is 20 mu watt divided by pz. So it is 0.8 into 30 divided by 10 equals to log 200 mu watt divided by pz. So from this it is 2.4 log 200 mu watt by pz. So here it is pz by log equals to 10 to the power 2.4. So from this we will get from the calculator, the help of calculator, that is it is 0.7962 mu watt. This is the answer. Amisha Shahu.
Yes, sir.
Just few minutes ago I asked a question to you, so in that time I am not getting the any responses. Is आपने क्लास में था या नहीं था?
सर नेटवर्क इशू था. सॉरी सर.
One thing I am here mentioning, that if you don't want to do the class without the proper attention, you won't do. because I am here discussing the problem for you.
Sorry, sir.
Next problem. Next problem, that is a continuous 12 km long optical fiber link has a loss 1.5 dB per km. Okay, there is two questions. First one is determine the maximum optical power level if the minimum launched power is 0.3 watt. And the second question, that is what is the required input power if the fiber has a loss of 2.5 dB per km. So there is two questions. So first is that it is given that a continuous 12 km long optical fiber link has a loss of 1.5 dB per km. And the first question, that is determine the maximum optical power level if the minimum launched power is 0.3 mu watt. And the second question, that is what is the required output power if the fiber has a loss of 2.5 dB per km. Already you saw two problems, this type of problem, so just do it now.
सर फर्स्ट वाला का 18.9 होगा।
सॉरी फर्स्ट वाला का आउटपुट कितना?
सर 18.9।
No, it is not 18.9. I'm getting only one response. I asked this question for all of the participants. Okay, so now we just focus for this problem here. Okay, so I am erasing this problem. So first of all, here it is given that z equals to 12 kilometer and alpha equals to 1.5 dB per km, and P naught that is also given, that is 0.3 mu m. Okay, so the attenuation constant, the formula is alpha equals to 10 by z log P naught by Pz. So it is 10 by 12 log value of P naught, that is 0.3 mu watt by Pz. So here I am writing next part here. Okay, so it is log 0.3 mu watt divided by Pz equals to 1.5 divided by 0.8 P3. So it is equals to 1.80. So from this step, actually the next step is 0.3 mu watt by Pz equals to 10 to the power 1.8. Pz equals to 0.3 mu W or watt divided by 63. So from this calculation, you will get the answer, that is 4.76 into 10 to the power 9 watt. The answer is here written in watt. Okay, this is the first answer. This is the first. Now the second problem, for the second problem, I'm erasing this. Second problem, second one, that is here we want the input power. So here the lambda, sorry, alpha is given, that is 2.5 dB per km. So alpha equals to 10 by z log P naught by Pz. So 2.5 into 10 by 12 log P naught by 4.76 into 10 to the power 9. So it is 10 to the power minus 9 goes to 2.5 divided by 0.833. So it is almost 3. So next is P naught by 4.76 into 10 to the power minus 9 equals to 10 cube or 1000. So the answer from this P naught equals to 4.76 mu watt. This is the second answer for this problem. Okay. So this type of problem you may get in your semester examination, how you will calculate the attenuation loss. So for attenuation loss, you can get this type of problem in your semester examination. Okay, so the almost the time is over for the first class, and after ending this session you just join same link after 5 minutes. Okay, so now I am ending this session and you just join the same link after 5 minutes. Thank you.